In this question, we're going to talk about basic grounding. And we're going to do it by just having a charged can and we're going to ground it. So in part one here, you'll see there's a charged can with a negative charge. We'll represent that with a square box. And I'm going to make it have, I'm going to start by just making a neutral. So 4 pluses, 4 minuses. That would be an overall zero or neutral charge. But we want it to be minus, so we'll put in 4 negatives. And remember, the negative electrons are going to spread themselves out as far away as they can get, so they'll go to the corners. So now we're going to go to the next step where we're grounding. Grounding is the concept where a charged material will connect with something much, much larger than it that can absorb its charge very easily, such as the Earth. And the symbol for grounding is like this kind of arrow. It doesn't always have to be the Earth, it just has to be something much, much larger. Like for a car, it's the chassis of the car. Humans can ground things that are much like tiny charge, like static electricity off a doorknob. But for this case, we'll just go right to the ground. The ground has a lot of electrons to give or take. It can absorb a bunch of electrons and not even notice it. Now in this picture, it's the human taking it, and with a can, that would be very possible. There wouldn't be a lot of extra charge in a can. But you remember, the human is touching the ground too. And so the charge would flow, if it was a lot, would flow through the human to the ground. That actually could be a very bad thing because the human would be connecting the circuit and the human could really experience basically a huge shock. So not a great idea to ground a huge charge. But with a can, a human would absorb the electrons. So in this case, these electrons, they don't really want to be in this can right now. They're trying to get as far away as possible. And so basically, when the ground is connected, they have an avenue to escape. And so let's do that. So the electrons are going to travel. They're going to get out of this can. And they're going to go to the ground, which is going to have so much space for them that they won't even really notice. So it's got all the, and there's way a lot of space for them to separate, and the ground is always giving and taking, so it won't notice. So that's basically all there is to it. Once you cut the ground, which is the next step, so once the ground is cut, the charges are stuck in the ground. But that's okay because the ground is so large that it's really insignificant to the ground. You can absorb it. And we're left with a can that is neutral. And of course, out of the 4 ways of charging a material, this would be grounding. And what you're going to notice as you do these problems is it's not always that simple. Sometimes you'll have something with a charge. And let's say this has a plus minus, but it has, well, let's just say it's neutral. And then something comes along and we have a little induction happen. So this is a negatively charged balloon, for example. It's negatively charged. And as it gets close to this can, these electrons want to get as far away from that negative charge as possible. And they can move because this is a conductor. And in conductors, electrons can move. So what they do is they run as far away to the edge as possible, right? And now we have these electrons on the run, so I'm going to make them red now. And they've moved all the way over here. Now usually with a ground, it's going to make something neutral. But in this case, so here's the ground. And we have it will absorb or give electrons. And usually it's to make something neutral. And as soon as it touches here, though, the electrons aren't going to go up, but they are going to go down, basically because they're being pushed by that negative balloon. They go down into the ground because this negative balloon is inducing them to basically run. And at that point, if that ground is cut, one of two things can really happen here. This can be cut, and if it is cut, then the can is permanently positive because the electrons can't go back. So it'll be positive. But let's say we get rid of the balloon at this point. Let's say we get rid of this balloon and we just get rid of it. And at that point, there's nothing pushing the electrons down, and we have a positive can connected to the ground. So the ground is actually going to give back those electrons. It's going to go back. And this electron is going to go back. Same with this one. It's going to go back. And we have, once again, what we started with, a neutral can.